here, chapter 3. One of the most important questions in chapter 3 about what? About here, the law of multiple proportion. The law of multiple proportion says what here? If you have two elements, whatever the two elements, and they can form more than one compound, the relationship between them is known as law of multiple proportion. Let's see the following. If you have C and O, now I have two elements, carbon and oxygen. They can form carbon monoxide and carbon dioxide. This law says what? This law says the following. Now I have two elements, carbon and oxygen. They can form carbon monoxide and carbon dioxide, two different elements, this one and this one. But the compounds here, I have two compounds. The law says that there is a relationship between the two elements in the compound. This one is known as law of multiple proportion. How can you differentiate? How can you answer the question? Check the two elements. Yeah, this one, hydrogen and oxygen, and here, hydrogen and oxygen. But this compound, H2O, the second one, H2O2. So they are two different compounds. So they can represent this law, which is known as law of multiple proportion. Law of definite proportion is something else. It's about what? About two elements can form a given compound, but the two elements with given ratio. For example, you have H2O, that is water. Why here? I have here hydrogen and oxygen. The ratio between them 2 to 1. I can't say H3O is water. Why? Because the ratio 3 to 1. But the original ratio between them is 2 to 1. Another example here, question number 9. Which of the following compound represents the law of multiple proportion? Yeah, here, carbon, oxygen, maybe this one. Magnesium, oxygen, no, this one, completely different compounds. Here, KCl and KBr, also complete different elements, so this one is not an example of multiple proportion, but this one is an example of multiple proportion. Another idea here about what? About how can we separate the components if you have mixture. One of them is known as chromatography. Chromatography is specified for something like dyes, chemical compound with color, like proteins, amino acids in proteins. So for organic compound, the idea, you can bring, right, a beaker like this, and then you can add inside this beaker, or you can insert inside it, right, something like this. What's this? A paper, for example, a paper chromatography, like this paper. And then we draw a line at the beginning of the paper, a special kind of paper. We draw a line here and line here. And then we add the spot of the dye or the ink here in this area. Once it imbibes water, water can go like this, and then it separates the parts here into different parts. So the idea, you have dye, you have pigment, you have proteins, you want to separate its component. Once you put them inside another liquid, this liquid starts to migrate step by step, and then separate them into two or more different regions. By a specific method, we can separate them. So here, ink, it can be separated by chromatography. The last question here about what? About the ratio. Here, he said that on electrolysis of water, as you know, water, right, contains H2O. 60%, right, I have here 20 grams. 60% of it is what? Here, 60% oxygen gas. It means that the another one will be 40% for hydrogen, this one for oxygen, this one for hydrogen. Why? Because the total will be 100%. Now, the compound H2O, I have 60% oxygen. He said that 60% oxygen and 40%, right, hydrogen. Now, 60, right, and you start with 20 grams. So 60 times 20 grams divide 100 equals 12 grams. Means that the amount of oxygen is 12 grams. And you can understand that if I start with 20, the amount of hydrogen will be 8 grams. That is the idea. He needs to know the mass of hydrogen is 8 grams. Thank you.